Good morning, calculus. So for the AMI day today on Thursday, what you're going to do is you're going to watch this video. You're going to take down your copy of the notes from topic 614, and then you're just going to submit a copy of the notes to show that you did watch the video, and then you get credit for attending class. If you're away with robotics or whatever, I'll just leave this assignment open for you and you can watch this video when you have time, submit your notes. We know you guys are supposed to be away from school today anyway. All right, topic 614. It says topics 6, 11, 12, and 13 cover concepts tested in AP Calculus BC, so we don't cover those. But what this topic will do is it will go over all of our basic integration rules from this unit. So we're going to look at problems that look very similar, but yet we have to integrate them in different ways. So the first one, if you notice with example 1, they all have a denominator of x squared plus 9. So you might think to yourself, okay, I'm going to try some u substitution. So up here, I'm just going to put that u equals x squared plus 9, du is 2x dx. Okay, that's all good and well. Let's see, I'm going to be looking for an integral then that has at least 2x in the numerator so that I can do some u substitution. A does not have that. B does if I rewrite it. So if I rewrite this as 2, and the integral of 2x over x squared plus 9, then I'm going to have my u substitution because this right here is my du. All right, so I'm going to carry on then. That's going to be 2 times the integration of du over u. And that's going to end up being 2 times the natural log of x squared plus 9. Now that's always positive, so I'm not going to put it in absolute value bars. And then plus c. So that one can be done with substitution. Whenever I look at part A, I'm going to go back and look at page 30 in my notes. Page 30 has my inverse trig u substitution form. So the one that has a squared plus u squared is for arctangent. That one would best fit here with our part A. So I'm going to pull my 4 out first, and that's dx over, and then I'm going to write it as 9 plus x squared. My a squared is 9, my a is 3, my u squared is x squared, my u is x, therefore du equals dx. So this just follows arctangent. Arctangent says I take 1 over a, I have the arctangent of u over a, and then plus c. And you can put the angle in parentheses. So there's our part A. Part C, I think you saw some of these in your last skill builder that you were doing for lesson 410, where we have to do long division to start. Now, I know I alluded in class that when your numerator's degree is higher than the denominator, you will need to do long division. You can also do long division, as you saw in your skill builder, when the powers are exactly the same, when the degrees are the same. So I'm going to take 4x squared and divide that by x squared plus 9. I'll have a, 4 up here, and then a plus 36. Then I'll subtract. I'll get a negative 36 out of that. So this is the same integration as 4 minus 36 over x squared plus 9. All right. Well, we just integrated with a denominator of x squared plus 9 over here with part A. So it's going to be the same arctangent piece going in, except I'll be multiplying it this time by 36. Okay. So here we go. We'll have 4x minus 36 times 1 over 3 arctangent of x over 3 plus c. And we can just clean that up. And there we have it. All right, moving on to number 2. Again, 3 problems that look a lot alike. Oh, hang on just a second. I had a file open on my computer and it just closed. Pause with me just a minute. Okay. For part or number 2, of course your u to u is probably going to be x squared minus 1. You guys have been taught to kind of look for what's under the radical. Your du is 2x. So again, I'm looking for a problem that would have a 2x or at least an x in the numerator so that I can do some u substitution. Let's see, the only one that has that is part B. It's going to need a 2 on the inside and a 1/2 on the outside. So I will be integrating 1/2 of the integration of u to the 1/2 du. So integrate u to the 1/2 du. Oh, and that's going to be a negative 1/2 because I need to pull it up from the denominator. Okay, what we're going to have to do next is add 1 to that and get 2. And then that would be u to the 1/2. So we're going to end up with x squared minus 1 to the 1/2, which is the square root, plus c. Now technically I don't need these parentheses there. Okay, that one's done. And then from here I'm going to look for other patterns that I know about. So I'm going to go back to page 30 in my notes and see if any of these fit what I have in my denominator. So if I look at arc sine, it does not have this x sitting out here on the outside. So I'm thinking that it's probably not arc sine. It doesn't look like arctangent, but it does look like arcsecant because it says u squared here and then u on the outside, and I do have that. So let's go ahead and try that with arcsecant. So we're going to say u squared is x squared, du is dx. Oh, I jumped the gun on you, sorry. U is x, so du is dx. A squared is 1, so a would be 1. And it fits right into arcsecant. So we're going to say 1 over a, which would just be 1. I'll go ahead and write it out for you. Arcsecant, I need to make some more space. Okay, let me just start that over. 1 over 1 is 1, so 1 arcsecant. And then u over a, u is x over 1, and then that is in absolute value bars, plus c. We want to keep our angle positive for that. All right, now for part C, the only thing that looks remotely close is the formula for arc sine. So arc sine is du over the square root of a squared minus u squared equals whatever. Notice this is a squared minus u squared, so this has to be a constant that leads. You don't have that. You have u squared leading. You have u squared minus a squared. And because you have u squared minus a squared, this problem is not possible with what I'm teaching you in Calculus AB. So we're just going to say not possible with techniques from Calculus AB. This is a type of question that you would explore in Calculus BC, or if you're in college, Calc 2 or Calc 3. All right, here we go again with another set. This one has the natural log written all over it. So let's see here. I'm going to start with this one here. I'm going to say u is the ln of x. Du is 1 over x dx. And I actually have that. This is 1 over x dx right here. So I'm going to be integrating 1 over u du. And that is the natural log of the natural log of x plus c. I believe on the circuit that you turned in, that big long substitution circuit, you actually had a problem just like this. Let's try this next one. Let's see here. If I let u be the ln of x again, and u prime, or du, let's write it the way we've been doing it, du is 1 over x. I've got that right here again. So this just becomes the integration of u du. So u substitution works beautifully again. And that's going to be 1/2 u squared plus c. So 1/2 of the ln of x squared plus c. Okay. Part C, if you scroll through all of your notes, you're not going to have a formula for just the ln of x. So this is another one that's not possible. With techniques from Calculus AB. And then we're going to move on to the back side. Okay. It says the integrals in examples 1, 2, and 3 might seem fairly straightforward. Sometimes, although rare, the integration technique that is required can be disguised in many ways. All right, so interesting integration by substitution. Again, turn to your page 30 and kind of stay there for a minute. What you're looking at here is a denominator, and it looks to you like it's, again, u squared minus a squared. So it looks like from the start you won't be able to use arc sine because these two terms down here need to be switched around. All right, so what we're going to do is just try a little bit of manipulation here. What if you went ahead and said u squared was e to the 2x, and then u would be e to the x. That means du is e to the x dx. Okay. Well, let's see. What can we do with that? Let's play with that for just a quick minute here. That means I'm going to have to introduce an e to the x up here to get e to the x dx. And then if I put one on top, I'll also have to put one on the bottom. So hopefully that makes sense. I'm manipulating again. I need to get this for my du. And if I introduce one of those on the top, I need to introduce it on the bottom, so they divide out to be 0. So now this is starting to look like du. And then you have outside, you have u, then you have u squared minus a squared. So now it's starting to look like the arcsecant formula. And the arcsecant formula says I'm going to take 1 over a, arcsecant, absolute value of u over a plus c. And so my a is 1 because a squared is 1. So I'll have arcsecant, the absolute value of u. So that's e to the x. Now e to the x is always positive, so I can get by with just parentheses there, plus c. And then we have this one. And with this one, you can always take and split it up. You don't have to look at it as one integration. So I'm going to split it. And I think we've done a little bit of this with some other problems that we've seen in the unit. So split it up. And then we're going to try some different techniques for each side. So knowing that I see the x on top for this one, that leans me towards u substitution, because I see that derivative has an x in it. And that means I need a -2 here and a -1/2 on the outside. Okay. And for the other one, I'm going to have one of my trig forms again, or one of my inverse trig forms again. It looks to me like this could be a squared minus u squared. So I think I'm going to go with that route. So I'm going to say a squared is 4, so a is 2. U squared is x squared, so u is x, so du is dx. Don't need anything extra there. In fact, if you want, this 2 can always be taken out here if it's bothering you, so that 2 can be written in the front as well. All right, over here we have some u substitution going on. -1/2, the integration of 1 over u to the 1/2 du, and over here we're going to have the arc sine showing up. So it's the integration of 2 a squared minus u squared du, and everything's there like we need it. So -1/2, I'm integrating u to the -1/2. I'll add 1 to that and get 2. I'm sorry, I'll add 1 to that and get 1/2. I'll end up multiplying by 2. And then I'll have the arc sine of u over a plus c. And we'll finish that off with the negative square root of 4 minus x squared plus 2 arc sine of x over a. Oh, a was 2. Let me fix that. Grab my green pen. There we go. Plus c. Now, we're good there. I will also tell you that some textbooks, and it's probably good practice to do this, I just treat it as 2 separate problems, but when you guys go to college, some of your teachers might do the following. Since you're dealing with a u on the left for the left problem and a u on the right problem, and they are different, they will call this u1 all the way through. So I'm integrating u of 1. And then over here, they are going to call this guy u of 2. So they'll give him a name that's different than the other one. So just so you know, if you start seeing subscripts, that's just distinguishing the left u from the right u and showing you, telling you that they're different values. All right, and that is the end of your unit. So again, to get attendance credit for attending today, I need you just to submit a copy of these notes on Canvas, and I'll have a separate assignment on there for you. And then what you need to do is just carry on and finish up your last skill builder and start working on that test review.